5.1 Graphs of the sine and cosine functions. We're going to look at the sine first. Here's a picture of the unit circle, and then this is what the graph of the sine of theta would look like on a normal coordinate system. So the y values are here, the x's are there, and we're going to use the angle of rotation as our x. So for example, if you rotate this much, and these are the special triangles, so if that's 30 degrees, then this y value should go with pi over 6. You rotate another 30 degrees, now you're this high, and then that y value corresponds to pi over 3, and we continue that. Okay, so we get a 1 over here, and then at that point we start coming back because, values become less and less until you're at 0 over here, and you see you go all the way down to -1 at some point over here, and you're back at 0. Okay, some things you need to notice. First thing is that the sine is never worth more than 1. This is the highest point, or less than a -1. Okay, so that means that the range for the sine of theta is a -1 to 1. It will be the same for the cosine of theta. If you pick values larger than 2 pi, then you will just keep repeating this pattern. So this is a pattern here. And the reason for that is because after 2 pi, you are exactly one rotation. And then after that, you come back to these same values. And that implies, or that means, that the sine function is periodic. And so, periodic means that the values for f of x or f of theta repeat. And in the sine's case, and then the cosine as well, for both the sine and the cosine, the period, that would be how long does it take before things start repeating, the period is 2 pi. Okay, and then the other thing is that the sine and the cosine both have a very specific pattern. So I'm going to make a regular xy table, except the x's here are thetas. So there's theta, and then f of theta would be the sine of theta. That would be our y value, right? So the sine of theta, which is the y value, which could also be written as f of theta. So if you don't rotate, the sine is worth 0, because you don't have any height. And then we get all these values. Well, if you graph the sine of theta on a normal coordinate grid, you don't really need these values here and here. You just want to know how high does it go. Well, that maximum height occurs at pi over 2. So at pi over 2, you're 1. And then how long does it take to get back down? Well, until you're back at pi. And at pi, your sine is worth 0. And then if you rotate all the way out to 3 pi over 2, you see that the sine is worth a -1. And then 2 pi is sort of our ending point, because now we're back at 0. This here is our sine pattern. Okay, and that's what I'm referring to here in just a little bit. Okay, so keep those things in mind. So, how do you graph either a sine or a cosine? Well, the first thing is that you find the period. Okay, and for the period, we use 2 pi for the sine and the cosine, and we use the number in front of theta. You'll see that here in a second. Then we're going to use the period to figure out what you count by. And the count by is the steps that you need to go from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. So the count by, in this case, here was pi over 2. And the count by splits our period into 4 equal parts. Okay, and that's really what we want, just 4 equal parts. Then we make a table, then we use the pattern of the y values. So that's the pattern that I just tried to explain, and then we're going to finish. Okay, so what does this look like for the sine of theta if you didn't already have the graph? Well, the period for the sine is 2 pi, and then we're going to divide by the number in front of theta. So in this case, the number in front of theta is 1, and 2 pi divided by 1 is just 2 pi. Then we're going to multiply by 1 over 4. That will get us our count bys, and that will be pi over 2. So that is our count by, and this is the actual period for this function. So the period is how long it takes when you start at 0, how long does it take before values repeat? Well, out to 2 pi. The count by is what you need to do to be able to divide this into 4 equal parts. So if you start at 0, and if you add pi over 2, plus pi over 2 would be 2 pi over 2, which is pi, and then we get 3 pi over 2, and then 4 pi over 2, which is 2 pi, then we can graph our function with a nice smooth curve. Now the only thing that's left then would be to find the actual y values. So after you find the period, and after you find your count bys, you can start making the top line on your table. So 0, pi over 2, 2 pi over 2, which is just pi, 3 pi over 2, and then 4 pi over 2, which is 2 pi. And then the sine of theta goes here. And then what goes in this particular spot over here, this is the pattern of the sine. Now once you've figured out your count bys and or the period and the count bys, you shouldn't have to worry about it anymore. And what I mean with that is that the sine starts at 0, then goes to 1, back to 0, down to -1, and then back to 0. This should be in every table that you make for me. This should be in every table that you make for a sine or a cosine. Okay, and if there's anything else to do, now would be the time to do it. But you see we don't have anything else to do. So we can actually graph this. So that was 1. That's -1. We're going to start at 0. We're going to go up to 1, down to 0, down to a -1, back up to 0. And then you draw a nice smooth curve. Hopefully yours looks a little better than mine. Don't finish at the dot. Imply that this thing does continue because it could go, we could plug in negatives, right? And we could definitely plug in more than 2 pi as well. All right, next, let's do a cosine. So the pattern for the cosine is different than the sine, and we should be able to figure that out. So let's do that in gray. I'm going to make a unit circle here. So that's circle. Let's pretend that that went through the middle, which it clearly missed, but that's okay. And so it will be the same thing for the cosine in the sense that we don't need all values, we just need these values here. So what happens at 0, what happens at pi over 2, pi, 3 pi over 2, and then back to 0 or 2 pi. And the coordinates on the unit circle would be 1, 0 here, 0, 1 there, -1, 0 here, and 0, -1 there. And hopefully you also know that the cosine of theta is the x value of the coordinates on the unit circle. Well, if you keep that in mind, then you can see that the pattern for the cosine will be different. Because the first x value we see is 1, then it goes to 0, then it goes to -1, back to 0, and up to 1. So this little chunk over here should be in every table that you make for a cosine. This is in every cosine table. All right, now let's graph the rest of that mess. So what do we have? First step was to find the period, and the period is 2 pi, and we're going to divide by the number in front here. So think of this as 2/3 times theta. So this is the cosine of 2/3 times theta. So we're dividing by 2 over 3, which is multiplying by the reciprocal. So we're going to cancel that. This 2 cancels with that 2. So the period is 3 pi. So that is the period for this function. We're going to multiply by 1 over 4. Keep in mind again, what we're trying to do is if we start at 0 and we end at 3 pi, then how do I divide this in 4 equal parts? Well, you multiply by 1/4. So we need to count by 3 pi over 4. So this is our count by. So starting at 0, plus 3 pi over 4, etc., etc. So theta. See if we can make the lines a little neater. We're going to count by 3 pi over 4. So the first one we start at 0, plus 3 pi over 4. So 6 pi over 4, which is 3 pi over 2. And 6 pi over 4, right? And 6 plus 3 pi over 4 is 9 pi over 4, which does not reduce. And then 9 plus 3 is 12 pi over 4, and that should be the end. So 12 divided by 4 is 3 pi. So it worked. Okay. You often run out of room on these things, so you don't have to label every point. So I'm just going to label the first. Well, I didn't even label the first, but that's clearly the origin. Then that's the middle, and then that's the end. And then the next line would be, what is the cosine of 2 over 3 times theta? So I'm not worried about the 2 over 3 anymore. I already took care of that by finding the right period and the count bys. So now I should just be able to copy these values here. So pattern is 1, 0, -1, 0, and 1. So the cosine goes from 1 to 0 to -1 to 0 back to 1. Okay, and then we graph it. Now don't start here and run your graph this way, because the largest value we can get is 1, right? So this graph actually bends right there. That's a maximum. And it goes through 0 to the minimum, back to 0, back up to the maximum. So you need to make sure you bend it on both sides over here and over there. And I should probably mark that as 1, and then that's a -1. Okay. All right, do one more of these. We'll run through the general steps first. So, excuse me, steps to graphing. So the C here refers to what if you have a number in front, or it could have been behind. So what happens if there's a 3 here? Then plus a times the cosine. So here a is actually a -2, because I could write this as 3 plus -2 times the cosine. The 4 is the number in front of theta, so that's going to mess with the period. So what do? Well, you find a period first. After that, we divide the interval into equal chunks, right? So we're dividing it into 4, so multiply by 1 over 4. We're going to create a table. We're going to use the pattern for the sine. So this was our sine pattern, and if it's a cosine, it will be this one. So I'm going to use this pattern, so I should see this in my table, and then I should be able to plot the points. Well, after I finish the table. So let's see what we have for this one. So what is the period? So the period normally is 2 pi, and we divide by the number in front of theta, so 4. So this function has a period of pi over 2. So after pi over 2, you're already back at the start, so it's pretty fast. Oh, I don't want an equal sign there. I'm going to multiply that by 1 over 4 to divide it into 4 equal chunks. So this means that pi over 8 is what I count by. So I'm going to count by pi over 8 in my table. So if I start with theta, then starting with 0, I'm going to add pi over 8. So start at 0 plus pi over 8. It's 1 pi over 8, 2 pi over 8, which is actually pi over 4, 3 pi over 8, which does not reduce, and 4 pi over 8, which is actually pi over 2. And that is the period. So that's sort of a little check. Okay, what else do we have? So the next line then should be just what is the cosine of 4 theta. And this is your pattern. So your pattern for the cosine is start at 1, down to 0, -1, 0, back at 1. So you see I have the pattern that I have over here. Okay, next thing is to do what? We need to now change this so that it actually starts to look like this. So now what does the -2 do? Oh, well, the -2 is multiplying the cosine of 4 theta. So a -2 times 1 is a -2, and -2 times 0 is 0, 2, 0, -2. So this -2 is not really actually different than, what if the function I had was a -2x squared? Wouldn't the negative flip the x squared and the 2 increase the y values by 2? Well, by a factor of 2, sorry. So that's what it does over here. Or in the last part then is to write this as 3 minus 2 times the cosine of 4 theta. Well, this 3 is a positive 3, so it's added. So we're just going to add. A -2 plus 3 is 1. 0 plus 3 is 3. 2 plus 3 is 5. 0 plus 3 is 3. And a -2 plus 3 is 1. And then that is what I need to graph, that last line. So let's see, we need to go up to 5. We actually don't have any negatives on this one. So there we go. I'm going to go out to pi over 2. And when I divide that into 4 chunks, that means I should have pi over 4 in the middle. And then that's 1, that's 2, that's 3, that's 4, that's 5. So this one starts at 0, starts at 1. Then we're going to 3. Then at pi over 4, we should be at 5. Down to 3 again, back down to 1. And so the overall graph looks like this. So notice that we sort of get a new little middle line over here. What I mean with that is that this used to be our x-axis, right? And the graph starts low, goes up to the maximum, and then comes back to the low because it's flipped. Because it is a cosine, and cosines usually look like this. Oh, sorry. So cosines usually look like this. But we flipped this. So this dot was flipped over here, this dot was flipped over here, and 0 mirrors into itself. So this is what the flipped cosine looks like. So that is exactly what you should be expecting. And when you do a couple of these, you'll start getting the hang of this. And hopefully this will make sense. Thank you.